Welcome back, folks. We're going to look at another example of using the shortcut to do mesh analysis, sometimes called mesh by inspection. We're looking at another problem that has a current supply in it, and this is going to be the other case of the current supply. It's the first one we looked at that had a super loop in it. So we can still do this with mesh by inspection or the shortcut, whatever you want to call it, but we have to still recognize that there's a super loop. So that's why we started with that, and now we're doing this. Okay, so let's take a loop at this problem. It's a problem that we've seen before, and get my microphone just out of the view there. And let's see here. I see two meshes, so it's going to be a 2x2 system. Let me squeeze it in down here. Okay. It's going to be a 2x2 matrix inverted and multiplied by a 2x1 vector. And when I perform that operation, we're going to have our unknowns, I1 and I2. Right now, let's just try to find the mesh currents. If we find the mesh currents, we know how to go find everything else. So the kind of important thing right now is find the mesh currents. Okay, and ultimately we're going to get some numbers out of that. And I'll even duck out of the way if we can't see them there. So looking at this problem, two meshes, okay, two unknowns. I see a current supply, so I am going to write a KCL. Okay, and this is going to be the super KCL for I1 and I2. The other equation that I'm going to write is going to be a KVL, and this is going to be the KVL for those two meshes as well, so it's going to be the super KVL that's around both of those together. So we have a plan. That's good. And the first thing you should do is formulate your plan. So in this row, I'm going to write the KCL. And in this row, I'm going to write the KVL. The KCL is not too different. Right? These are the coefficients for I1. These are the coefficients for I2. So here I say, does I1 touch the current supply? And that's usually a question I would ask you live, but we're not live. So hopefully you can see that I1 is flowing around here, and it does flow through the 6 amp supply. So it does touch, and then I have to ask the follow-up question, which is, does it flow in the same or the opposite direction? So take a look at that, and you can see that it flows in the opposite direction. Since it's the opposite direction, it's negative. And then we move on to the next one. Does I2 touch that current supply? Sure does. So it's going to be a 1. And then does it flow in the same or opposite direction? And it flows in the same direction in this case, so it's positive. I'll even put the positive in there just to be explicit about it. The right-hand side for this equation is whatever's labeled here, and it happens to be 6. That one's done. Okay. Writing the super loop KVL, we got to think about the path that we're taking. So I don't really draw these unless I'm teaching. You know, if you do these enough, you can kind of see where the path is without having to draw it, but I think it's worthwhile drawing it since we're still learning. Okay, so we're going to modify the questions that we ask a little bit when we're moving around the super loop. I1 and I2 are the two meshes that form the super loop, and we only have two right now, so there's nothing that the super loop's going to share with another mesh. We'll look at that in the next problem. But we have to say, what does I1 touch that's on the super loop? And I1 is part of the super loop. Okay, so I1 touches this 6 ohm, and that 6 ohm is on the super loop. So because it's on the super loop, it is positive, and since it's 6, it's only going to be the 6 there. Look at the R2. I1 does touch it, but it is not on the super loop, and it didn't get included down here. So pay attention to that. And we're going to go do the same thing over here. What does I2 touch that's on the super loop? I2 touches the 10 and the 4, but it doesn't touch this 2. So it's going to be 10 plus 4, and it's 14. And since I2 is part of the super loop, it's going to be plus. Okay? Not too bad, but a little bit of a wrinkle from what we've done in the past. Oops, get out of there. Sorry for breaking the fourth wall there with the image. On the right hand side, we play the same game as we did with an individual mesh. We say what voltage supplies are there. It looks like I go up 20, and that's it. So I'm moving up across the 20. There we go. Okay. From there, whatever you want to do, I'm going to throw it in my calculator. I've worked this problem. I'm pretty confident I worked it correctly, but I always like to check the answer. Certainly when I'm doing it for the live show, the recorded show for all of you, I want to make sure that I did it right. And the best way to do that is to just go ahead and enter it in the calculator and check to see that I get a consistent result. Okay. So when I solve that system, yeah, this looks familiar. Negative 3.2 amps and 2.8 amps. Those are my mesh currents. They're behind me right now. Okay. So I'm feeling pretty confident about that. Those numbers feel familiar to me. But I'm going to go pull up the analysis that we did when I was first introducing mesh not that long ago for you. And we're going to see that we got an identical result and an equivalent system. There might be some little differences, but it'll be equivalent. So let me scroll down here. Okay, get that right there. And then I have this all ready to go. And we can place that there. Hopefully you can still see that. It looks good on my screen. Let me just clean up that little artifact. Okay, and it looks like our mesh currents are the same. Look, negative 3.2 and 2.8. So the result matches. The differences in the KCL, it looks like it's identical, which is kind of nice. In the super KVL, it looks like everything has the opposite sign. And again, as long as everything has the opposite sign, you're okay. You can't mix and match, though. So this is positive 6, this is negative 6. Positive 14, negative 14. Positive 20, negative 20, and if you enter that in your system of equations, you're going to end up with an equivalent answer. Okay, it's not just equivalent, it's the same answer. You're going to get the same mesh currents. Okay, so we can handle super loops with this shortcut. It's a little bit of a trick, but we can do it, and we can do it quickly. I didn't have to write any equations other than just entering them directly into the matrix format. And then we can solve that directly using whatever means we want. We should look at a bigger one. So I want to go grab the next problem, and the next problem is going to have more loops, but it's also going to have a super loop. So if you're not quite comfortable with this, stay tuned, and we're going to take a look at one more of these. So stay tuned and good luck.